Hello students, I am Dr. Sangeeta Sharma, your science teacher. Today we will be continuing with chapter 13 of your science book, that is magnetic effects of electric current. And in today's video, that is part 9, exercises 1, we will be solving the problems given at the end of this chapter. So let's begin solving the problems. Students, question number 1. Which of the following correctly describes the magnetic field near a long straight wire? यहाँ पर बच्चों हमें मैग्नेटिक फील्ड किसका बताना है? एक लॉन्ग स्ट्रेट वायर का, और हमें पता है कि एक करंट कैरिंग स्ट्रेट वायर जो है वो मैग्नेटिक फील्ड प्रोड्यूस करता है, और उसका मैग्नेटिक फील्ड जो है वो किस तरीके का होता है? यस, concentric circles with the wire at its axis. So students, let's see what are the options and which is the correct option. So option A is the field consists of straight lines perpendicular to the wire. Is this correct? No. Option B, the field consists of straight lines parallel to the wire. This is also not correct. The C option, the field consists of radial lines originating from the wire. Students, this option is also not correct. So the D option, the field consists of concentric circles centered on the wire. This is the correct option. We know that a current carrying straight wire has magnetic field around it in the form of concentric circles. This we have read, students, that all these circles represent the magnetic field lines with the current carrying straight conductor at the center, or you can say passing through the center of all these concentric circles. So option D is the correct option. So the answer is D option. Now let's see the next question. Question number 2. The phenomenon of electromagnetic induction is A, the process of charging a body. Option B, the process of generating magnetic field due to a current passing through a coil. Option C, producing induced current in a coil due to the relative motion between a magnet and the coil. And option D, the process of rotating a coil of an electric motor. अब बच्चों यहाँ पर क्या पूछा गया है? यहाँ पर ये पूछा गया है कि इलेक्ट्रोमैग्नेटिक इंडक्शन जो है वो क्या होता है. तो स्टूडेंट्स, हमें पता है इलेक्ट्रोमैग्नेटिक इंडक्शन जो होता है वो रिलेटिव मोशन के कारण होता है. रिलेटिव मोशन किसके बीच में? बार मैग्नेट और एक कॉइल के बीच में. तो इसलिए यहाँ पे जो करेक्ट ऑप्शन होगा स्टूडेंट्स वो होगा ऑप्शन सी. तो आंसर सी जो है वो इसका करेक्ट ऑप्शन है. सो प्रोड्यूसिंग इंड्यूस्ड करंट इन अ कॉइल ड्यू टू रिलेटिव मोशन बिटवीन अ मैग्नेट एंड द कॉइल. Right students, now let's see the next question. Question number 3. The device used for producing electric current is called a generator, B, galvanometer, C, ammeter, or D, motor. Now students, what is asked here is, it is asked that which is the device used for producing electric current. Now students, we know that generator is the device which produces electric current, that is it converts mechanical energy into electric energy. So here the answer will be the A option, that is the generator. And we know students that generator are of two types, AC generator and DC generator, where AC generator generates alternating current and DC generator generates direct current. So here the answer is part A, that is generator. Now let's see question number 4. The essential difference between an AC generator and a DC generator is that A, AC generator has an electromagnet while a DC generator has permanent magnet. B option, DC generator will generate a higher voltage. C option, AC generator will generate a high voltage. And D option, AC generator has slip rings while the DC generator has a commutator. Now students, here what is asked is that what is the essential difference between an AC generator and a DC generator. तो students हमें पता है कि AC generator और DC generator के अंदर जो essential difference है वो उसके कंस्ट्रक्शन के अंदर होता है कि AC जनरेटर के अंदर हम स्लिप रिंग्स यूज करते हैं और DC जनरेटर के अंदर हम स्प्लिट रिंग, जिसे कि हम कम्यूटेटर भी कहते हैं, यूज करते हैं। उसी के कारण हमें आउटपुट के अंदर ऑल्टरनेटिंग करंट मिलता है एसी जनरेटर के केस में और डायरेक्ट करंट मिलता है डीसी जनरेटर के केस में। तो यहां पे जो ऑप्शन जो कि करेक्ट है वो हो गया ऑप्शन डी। सो द आंसर इज डी। AC generator has slip rings while the DC generator has a commutator. Now let's see the next question. Question number 5. At the time of short circuit, the current in the circuit A reduces substantially, B does not change, C increases heavily, or D vary continuously. Now students, here what is asked is that what happens at the time of short circuit. अब हमें पता है स्टूडेंट्स कि शॉर्ट सर्किट कब होता है, जबकि लाइव वायर और न्यूट्रल वायर जो हैं वो दोनों डायरेक्ट कांटेक्ट में आ जाते हैं। तो ऐसा जिन जिन कारणों से भी हो सकता है, यानी कि उनके ऊपर की जो कोटिंग है वो हट जाए या उसके ऊपर कोई डैमेज हो जाए जिसके कारण लाइव वायर और न्यूट्रल वायर जो हैं वो डायरेक्ट कांटेक्ट में आ जाएं, तो उसे हम शॉर्ट सर्किट कहते हैं। तो यहाँ पर स्टूडेंट्स जब शॉर्ट सर्किट होता है तो उस टाइम पे जो रेजिस्टेंस है वो रिड्यूस होके और करीब करीब जीरो हो जाता है। तो जब रेजिस्टेंस एकदम कम हो जाता है तो स्टूडेंट्स हमें पता है कि करंट जो है वो बहुत ज़्यादा हो जाता है, जिसके कारण स्पार्किंग भी होने लग जाती है, हीटिंग भी बहुत ज़्यादा होती है और जिसके कारण कभी कभार आग भी लग जाती है। तो स्टूडेंट्स यहाँ पर जो ऑप्शन जो करेक्ट होगा वो होगा ऑप्शन सी, इंक्रीजेज हेवीली, क्योंकि रेजिस्टेंस जो है वो रिड्यूस हो जाता है, ऑलमोस्ट जीरो हो जाता है, इसलिए करंट जो है वो इंक्रीजेज हेवीली, यानी कि करंट जो है वो बहुत ज्यादा इंक्रीज हो जाता है। सो हियर एट द टाइम ऑफ शॉर्ट सर्किट द करंट इन द सर्किट इंक्रीजेज हेवीली। सो ऑप्शन सी इज द करेक्ट ऑप्शन। Now students, let's see the next problem. Question number 6. State whether the following statements are true or false. यहाँ पे हमें हर स्टेटमेंट को ये जज करना है कि वो स्टेटमेंट करेक्ट है या इनकरेक्ट है, यानी कि ये बताना है कि स्टेटमेंट जो है वो ट्रू है या फॉल्स है। तो पहला स्टेटमेंट देखते हैं स्टूडेंट्स। स्टेटमेंट ए, एन इलेक्ट्रिक मोटर कन्वर्ट्स मैकेनिकल एनर्जी इनटू इलेक्ट्रिकल एनर्जी। नाउ स्टूडेंट्स, हमें पता है कि जो मोटर है वो मैकेनिकल एनर्जी को इलेक्ट्रिकल एनर्जी में कन्वर्ट करता है या इलेक्ट्रिकल एनर्जी को मैकेनिकल एनर्जी में कन्वर्ट करता है। यस स्टूडेंट्स, जो इलेक्ट्रिक मोटर होती है वो इलेक्ट्रिकल एनर्जी को मैकेनिकल एनर्जी में कन्वर्ट करती है। तो ये जो ऑप्शन है, ये हमारा जो स्टेटमेंट है ये फॉल्स हो गया क्योंकि ये इनकरेक्ट है। एक ऐसी डिवाइस जो कि मैकेनिकल एनर्जी को इलेक्ट्रिकल एनर्जी में कन्वर्ट करे वो इलेक्ट्रिक जनरेटर होती है, ना कि इलेक्ट्रिक मोटर। तो यहाँ पे जो ये ऑप्शन है, ये जो स्टेटमेंट दिया हुआ है स्टूडेंट्स, ये गलत है। सो द आंसर इज फॉल्स। नाउ लेट्स सी द नेक्स्ट स्टेटमेंट, द स्टेटमेंट बी। An electric generator works on the principle of electromagnetic induction. Now students, we know that the principle of electric generator is electromagnetic induction. So here this statement is correct. So we will write true. So the B statement is true because we know that the electric generator, let it be a AC generator or a DC generator, both work on the principle of electromagnetic induction. Right students? Now let's see the next statement. Statement C. The field at the center of a long circular coil carrying current will be parallel straight lines. Now students, we know that at the center of a long circular coil, which is also known as a solenoid, carrying current will be parallel straight lines. So we know that the magnetic field lines inside a current carrying solenoid is uniform magnetic field and it is in the form of straight lines. So here this statement is correct. So this statement C is true. Then students, statement D. A wire with a green insulation is usually the live wire of an electric supply. Now students, we know that the green insulation is for earth wire, and for live wire the insulation is of red color. So this statement is incorrect. Hence the answer for this statement D is false. Right students? Here we know that green insulation is for earthing, that is the earth wire, and the live wire is of red color. That is why this statement is incorrect. Right students? Let's see the next problem. Question number 7. List 2 methods of producing magnetic fields. Now students, we know that magnetic field are produced by sources of magnetic field. That is, the sources of magnetic field can be a current carrying straight conductor, a current carrying coil, or we can have permanent magnets, or we can have electromagnets. So all these are the correct answers to this problem. Now they have asked only 2 sources. So here we will write the answer like this. 2 methods of producing magnetic fields are current carrying conductors and permanent magnets. So here we have given the 2 options A and B. Right students? Now let's see the next problem. Question number 8. How does a solenoid behave like a magnet? Can you determine the north and south poles of a current carrying solenoid with the help of a bar magnet? Explain. अब यहाँ पर बच्चों 2 क्वेश्चंस पूछे गए हैं. यहाँ पर फर्स्ट क्वेश्चन क्या पूछा गया है कि एक सोलेनॉइड एक मैग्नेट की तरह कैसे बिहेव करता है, और दूसरे पार्ट में उन्होंने ये पूछा है कि हम एक बार मैग्नेट को यूज करके क्या एक करंट कैरिंग सोलेनॉइड का नॉर्थ और साउथ पोल जो है उसको हम डिटरमिन कर सकते हैं, उसके बारे में हम पता कर सकते हैं, और अगर कर सकते हैं तो उसका हमको एक एक्सप्लेनेशन देना है, और अगर नहीं भी कर सकते तो भी उसका एक्सप्लेनेशन देना है. तो यहाँ पर स्टूडेंट्स हमें पता है कि जो सोलेनॉइड है, जो कि एक करंट कैरिंग सोलेनॉइड अगर हम लें तो वो ऑलमोस्ट एक बार मैग्नेट की तरह बिहेव करता है. उसकी मैग्नेटिक फील्ड लाइंस जो हैं वो भी ऑलमोस्ट बार मैग्नेट की तरह होती है, और उसका एक तरफ तो नॉर्थ पोल होता है और एक तरफ साउथ पोल होता है. तो हम इसकी आंसर राइटिंग जो है स्टूडेंट्स वो इस तरीके से करेंगे. So the answer, a solenoid behaves like a magnet in the following ways. First, the magnetic field produced by a current carrying solenoid is very much similar to that of a bar magnet. And the point 2 is, like a bar magnet, one end of the solenoid has north polarity while the other end has south polarity. Now students, this is the magnetic field of a bar magnet, and we know that in case of solenoid also we are having similar type of magnetic field lines coming out of the solenoid. So here in place of this bar magnet we can have a solenoid also. So for the solenoid also what we see is that the magnetic field lines are almost the same, and as we know that here the north polarity and the south polarity depends upon the direction of the current. Now here if we want to have the north polarity, then we know that we have learnt this, that the north pole constitutes anti-clockwise current. That is, or we can say in another way, that if there is anti-clockwise current then there becomes a north pole, and if we have a clockwise current then a south pole is generated over that end. So here if we want to have a north pole here, then the current must be anti-clockwise here. So for anti-clockwise, and here the current must be clockwise. So what we see is that the polarity of the battery connected must be like this. So since the current will flow in this form here, from here from this end when we will see the current, then it will appear to be in clockwise direction. So a south pole will be created at this end. And here if we watch the direction of current, since the direction of current is like this, so if we watch the direction of current from that end, then a north polarity will be observed, because from that end the direction of current appears to be anti-clockwise in the coil. So students, what we see is that a current carrying solenoid behaves like a bar magnet. Now moreover, the next part is, they have asked that whether we can find out the north and south polarities of a solenoid with the help of a bar magnet. Now here students, we will use the attractive property of a magnet. What is the attractive property of a bar magnet? We know that like poles repel and unlike poles attract. So students, if we are going to bring a north pole of a bar magnet towards the north pole of the solenoid, then if repulsion occurs, then we must understand that the end of the solenoid is north. And if attraction occurs, then we come to know that that end of the solenoid where we brought the north pole of the bar magnet is a south pole. यहाँ पर बच्चों हम कैसे पता करेंगे कि एक बार मैग्नेट को यूज करके कि सोलेनॉइड जो है उसका कौन सा एंड नॉर्थ पोलैरिटी लेकर है और कौन सा एंड साउथ पोलैरिटी लेकर है? तो अगर हम बार मैग्नेट का नॉर्थ पोल सोलेनॉइड की कॉइल के पास लेकर आए और अट्रैक्शन हो, तो इसका मतलब क्या होगा? वो एंड क्या है? वो एंड साउथ पोलैरिटी लेकर है। और अगर रिपल्शन हो तो इसका मतलब क्या होगा कि वो एंड जो है वो नॉर्थ पोलैरिटी वाला है। सो स्टूडेंट्स, वी विल राइट द आंसर लाइक दिस। To determine the north and south poles, we bring north pole of the bar magnet near one end of the solenoid. If there is an attraction, then that end of the solenoid has south polarity and the other has north polarity. If there is a repulsion, then that end of the solenoid has north polarity and the other end has south polarity, because similar poles repel each other. Right students? So let's see the next question, which is question number 9. When is the force experienced by a current carrying conductor placed in a magnetic field largest? We know students that a current carrying conductor experiences a force when it is placed in a magnetic field, and we learnt that we determine the direction of this force experienced by the current carrying conductor by Fleming's left hand rule. Now students, here they have asked that when will this force be maximum? So we know that this force is maximum when the conductor is placed perpendicular to the magnetic field. So we will write the answer like this. When the conductor carries current in a direction perpendicular to the direction of the magnetic field, the force experienced by the conductor is largest. Right students? So let's see the next question. Question number 10. Imagine that you are sitting in a chamber with your back to one wall. An electron beam moving horizontally from back wall towards the front wall is deflected by a strong magnetic field to your right side. What is the direction of magnetic field? Now here students, they have asked us that imagine that you are sitting in a chamber with your back to one wall. That is, suppose I am sitting over with my back towards the board, that is the wall. Then an electron beam moving horizontally from back wall towards the front wall. So the electron beam is moving like this. That is, it is moving from the back wall to the front wall. Now students, we know that the direction of current is opposite to the direction of motion of electrons. That is, the conventional current is from a positive terminal to the negative terminal, and electrons move from negative terminal to positive terminal. Now here, since the electrons are moving from the back wall to the front wall, this means that current is flowing from the front wall to the back wall. Now what do we see is that this electron beam is deflected by a strong magnetic field to your right side. Now this electron beam, which is moving like this, that is, the current is moving like this, gets deflected towards the right side. Now we want to calculate the direction of magnetic field. So here, students, we are given the direction of current, we are given the direction of force experienced, and we have to calculate the direction of magnetic field. So here, students, we will use the Fleming's left hand rule to calculate the direction of magnetic field. So first we will write, students, that here the electron beam is moving from our back wall to the front wall. So the direction of current will be in the opposite direction, from front wall towards back wall or towards us. The direction of deflection और the force is towards our right side. तो बच्चों यहाँ पर ये तो क्लियर हो गया कि हमें क्या क्या दिया हुआ है. हमें दिया हुआ है डायरेक्शन ऑफ करंट और डायरेक्शन ऑफ फोर्स, और हमें क्या कैलकुलेट करना है, हमें कैलकुलेट करना है मैग्नेटिक फील्ड की डायरेक्शन. तो हम क्या यूज करेंगे स्टूडेंट्स, हम यूज करेंगे फ्लेमिंग्स लेफ्ट हैंड रूल, जहां पर थंब हमें किसकी डायरेक्शन देता है, फोर्स की डायरेक्शन, और फोर फिंगर जो है वो किसकी डायरेक्शन देता है, फोर फिंगर हमें मैग्नेटिक फील्ड की डायरेक्शन देता है, और जो सेंट्रल फिंगर है वो हमें करंट की डायरेक्शन देती है. तो यहाँ पर हमें क्या क्या दिया हुआ है, करंट की डायरेक्शन दी हुई है और फोर्स की डायरेक्शन दी हुई है. तो करंट की डायरेक्शन में करंट को रख देंगे, फोर्स की डायरेक्शन में फोर्स को रख देंगे, और देखेंगे कि मैग्नेटिक फील्ड किस डायरेक्शन में है. तो हमें पता है कि करंट की जो डायरेक्शन है वो तो टुवर्ड्स द बैक वॉल है, और फोर्स की डायरेक्शन जो है वो राइट हैंड साइड पर है, मेरे राइट हैंड साइड पर है स्टूडेंट्स, क्योंकि मेरी बैक जो है वो बैक वॉल जो है उसकी तरफ है, और फ्रंट वॉल से और बैक वॉल की तरफ करंट आ रही है, और मेरे राइट हैंड साइड पे जो है वो इलेक्ट्रॉन बीम फोर्स महसूस कर रही है. तो स्टूडेंट्स डायरेक्शन कैसे हो जाएगी, इस तरीके से हो जाएगी, आप देख पा रहे हैं. तो ये तो फोर्स की डायरेक्शन हो गई, और ये जो मेरी मिडिल फिंगर है, जो मेरी मिडिल फिंगर है स्टूडेंट्स, वो कहाँ पॉइंट कर रही है, टुवर्ड्स द बैक वॉल. तो मैं क्या देख रही हूँ कि जो मैग्नेटिक फील्ड यानी कि जो फोर फिंगर है स्टूडेंट्स, वो किधर डायरेक्ट कर रही है, वो डाउनवर्ड्स डायरेक्ट कर रही है, यानी कि वर्टिकल डाउनवर्ड होगा डायरेक्शन किसका, वर्टिकल डाउनवर्ड डायरेक्शन होगी मैग्नेटिक फील्ड की. तो इसे देखते हैं स्टूडेंट्स. We now know two things. Direction of current is from front towards us, and direction of force is towards our right side. So by Fleming's left hand rule, the direction of forefinger gives the direction of magnetic field. Therefore, the magnetic field is in the vertically downward direction. This we have seen students by stretching the three fingers of our left hand. We have seen that the direction of the magnetic field is going to be vertically downwards, since the direction of force is towards the right hand side and the direction of current is towards the back wall. Right students? Now let's see the next question. The next question is question number 11. Draw a label diagram of an electric motor. Explain its principle and working. What is the function of a split ring in an electric motor? नाउ स्टूडेंट्स यहाँ पर हमें क्या करना है, यहाँ पर सबसे पहले हमें एक लेबल डायग्राम बनाना है इलेक्ट्रिक मोटर का, और फिर उसकी प्रिंसिपल और वर्किंग को भी एक्सप्लेन करना है, और हमें फंक्शन बताना है स्प्लिट रिंग का इलेक्ट्रिक मोटर में. तो स्टूडेंट्स हम स्टेप बाय स्टेप, इसने जितने पार्ट्स पूछे हैं, 3 पार्ट्स के अंदर, 4 पार्ट्स के अंदर जो हमें आंसर देना है वो हम स्टेप बाय स्टेप देंगे. तो सबसे पहले स्टूडेंट्स हम डेफिनेशन लिखेंगे इलेक्ट्रिक मोटर की. सो स्टूडेंट्स, इलेक्ट्रिक मोटर इज अ रोटेटिंग डिवाइस विच कन्वर्ट्स इलेक्ट्रिकल एनर्जी इनटू मैकेनिकल energy. Then we will draw a label diagram of a electric motor. Now students, here we will show the magnet, that is having the north pole and the south pole. So here I have indicated the north pole, the south pole, and then we will show the rectangular coil which is made up of copper and is insulated, and this copper coil is known as armature. So PQRS is the armature which is attached to the split rings. Here we have shown the split rings, students, R1 and R2. So split rings R1 and R2. So we know that the armature is connected to the split rings R1 and R2. Then we have the brushes B1 and B2. So here we have shown the brushes B1 and B2 which are connected to the external circuit having a battery and a key. And here, students, this split ring are mounted over a axle. Now here, students, the direction of magnetic field is from the north pole to the south pole. So this also we have shown the direction of magnetic field. Now here, students, now we will understand the working of this electric motor. So here this is the labeled diagram of an electric motor, and now we will understand the working of this electric motor. Now students, before that we have to write the principle also. So the principle of electric motor is based on the principle that a current carrying conductor placed perpendicular to the magnetic field experiences a force. So this is the principle of electric motor. Now we will understand the working. So students, for the working, we will divide the working into two halves. So first we will understand in the first half rotation what happens, then we will understand for the next half rotation. So students, initially the armature is in a horizontal plane, R1 is in contact with B1 and R2 is in contact with B2. Now here in this figure we can see this clearly that we are having two strong poles, north and south poles, and the armature coil PQRS connected to the slip rings R1 and R2, which is hence connected to the brushes B1 and B2, and it is connected to the external circuit. Now what we see here is, students, that for the first half rotation, this PQRS, which is the armature, is held horizontal such that the PQ arm is in contact with R1 and the RS arm which is in contact with R2. And here what we see is that the brush B1 is in contact with R1 and the brush B2 is in contact with R2. Now what we see is that when the current flows, now here we are showing the battery, students. So this is the positive terminal of the battery and this is the negative terminal of the battery. So when the current flows, then the current flows in this direction. So the current enters the slip ring and hence the armature through this brush B2. So the direction of current is going to be like this. Now what we see is, students, that for the arm SR, the direction of current is upwards. The direction of magnetic field is like this. Then by Fleming's left hand rule, what we observe is that the direction of force is going to be downwards. Now how did we find this, students? Now here what we see is, this is the direction of magnetic field, this is the direction of current. So here, students, what you see is that this is the direction of magnetic field and this is the direction of current. So what we see is that the direction of force is downwards. This is for arm SR. So you can see this, students, magnetic field, the direction of current, and here this is the direction of force experienced by this arm. So here in this arm, the direction of force is going to be downwards. Now for this arm, what we see is that the direction of magnetic field is the same, but the direction of current is like this. So what will be the direction of force? Now here, students, what we see is that the direction of magnetic field, you can see it like this. This is the direction of magnetic field and this is the direction of current. So the direction of force, which is indicated by the direction of thumb, is going to be upwards. This is the direction of magnetic field, this is the direction of current. So this is going to be the direction of force experienced by this arm PQ. So here the force experienced is upward. So what we see is that this arm is having a downward force and this arm is experiencing a upward force. So the armature coil, which is placed horizontal between the magnetic poles will experience a force so as that it will rotate in a clockwise direction. This arm is experiencing a upward force, this arm is experiencing a downward force. So it will move like this. So what we see is that the armature coil will move in a clockwise direction. So this is for the first half rotation. Now once the armature coil rotates by 180 degrees, now what we will have is that after rotation the arm will be now like this. So what we see is that in the first half rotation, initially the armature is in a horizontal plane and R1 is in contact with B1 and R2 with B2. When the current flows in the armature, the force acting on SR is vertically downward and the force acting on QP is vertically upwards. So the direction of these forces have been found by Fleming's left hand rule. These forces rotate the armature in clockwise direction. This we have seen in the figure also, that what we have is that this arm is having a downward force, this arm is having a upward force. So the armature will rotate in a clockwise direction. Now we will understand this for the next half rotation. And students, for the next half rotation, this PQ arm after rotating will come on this side and this SR arm after rotation by 180 degrees will come on this side. Now we will see that what happens for the next half rotation. So students, in the next half rotation, after a half rotation of the armature, the plane of the armature again becomes horizontal. Now R1 comes in contact with B2 and R2 comes in contact with B1. This you can see here in the figure clearly, that now since the PQ arm which was initially on this side, now after half rotation, that is on rotating by 180 degrees, it has come on this side, and the RS arm which was initially on this side, after a half rotation has come on this side. So what we see is that now the PQ arm which was attached with R1 ring is now attached and is now in contact with B2 brush, and the arm RS which was in contact with R2 ring is now in contact with B1 brush. Now since this B1 and B2 are fixed as they are connected to the external circuit, and here the battery is also the same and this is the positive end, so the current will flow like this. So now since the B2 is in contact with R1, so the current will flow through the slip ring R1 in this direction. So what we see is that the direction of current is again anti-clockwise, but the direction of current in the arms have been reversed. In PQ, initially when PQ was here, what we saw was that the direction of current was from Q to P. Now it is from P to Q. And for this arm, the current direction is now from R to S. Initially it was from S to R. You can see this in the previous video, students. The direction of current was from Q to P and here it was from S to R. But now it is from R to S and it is from P to Q. So by Fleming's left hand rule, again we will calculate the direction of force, and as we know that the direction of force will be downwards in this arm and will be upward in this arm. So what will happen? This arm is experiencing an upward force, this arm is experiencing a downward force, so the armature will rotate in a clockwise direction. That is, the armature will keep on rotating in the clockwise direction in both half rotations. So students, since R1 was connected with B2 and R2 was in contact with B1, this ensure current flowing anti-clockwise in the armature. The force on RS is vertically upwards and on PQ is vertically downwards according to Fleming's left hand rule. Therefore, the armature remains moving in the clockwise direction. So now students, we will write the answer for the last part of the question, which was function of split rings for an electric motor. Now students, here function of a split ring in an electric motor. The split ring in the electric motor acts as a commutator. The commutator reverses the direction of current in the armature coil after each half rotation. Due to this reversal of the current, the coil continues to rotate in the same direction. सो स्टूडेंट्स, अगर हमारे पास में यहाँ पर स्प्लिट रिंग जो कि कम्यूटेटर का काम कर रही है वो नहीं होती, तो अगर आर्मेचर में करंट की डायरेक्शन जो है वो इस तरीके से नहीं होती कि रोटेशन सेम डायरेक्शन में हो, तो प्रॉपर फंक्शनिंग इलेक्ट्रिक मोटर की नहीं होती. तो स्प्लिट रिंग्स जो है ना स्टूडेंट्स, वो बहुत इंपॉर्टेंट रोल प्ले करते हैं इलेक्ट्रिक मोटर के वर्किंग के अंदर. तो स्टूडेंट्स, ये जो स्प्लिट रिंग्स हैं जिन्हें हम कम्यूटेटर भी कहते हैं, इनका मेन काम है करंट की डायरेक्शन को रिवर्स करना, जिसके कारण आर्मेचर कॉइल जो है वो सेम डायरेक्शन में रोटेट करती रहती है. और हमने जब पढ़ा था तो उसको हमने क्लॉकवाइज डायरेक्शन के अंदर रोटेट करते हुए दिखाया था. So students, today we have completed a few questions of this chapter, and in our next video we will do the rest of the questions. Till then, stay safe, stay healthy. Bye.